Okay, I'd like to say a word or two about the distributive law, one of my favorite laws of mathematics. Really, really cool, not that hard to explain. The distributive law states that A times B plus C is A times B plus A times C. And to prove it, we can use the area model of multiplication. That is to say that A times B plus C is the area of a rectangle that is A in one dimension and B plus C in the other dimension. And B plus C, as we've split up rectangles before, is B and then C. It breaks into two rectangles. Now, A times B plus A times C is two different rectangles. And A plus B, A by B, plus an A by C rectangle. And it isn't too hard to see that the two rectangles on the right can be smushed together to make the rectangle on the left. And that is why A times B plus C is the same thing as A times B plus A times C. Now, one interesting thing about this is that there's sort of a vocabulary, curious vocabulary thing here, which is that this is called distributing. We say we distribute the A. You have this B plus C, and we give each of them an A. We've distributed the A. A goes to there, and A goes to there, and it's called distributing. But if we just reverse the equality and say A times B plus A times C is A times B plus C, it's the exact same equality, just written the other way. This is called factoring out an A. You look at it and you say, oh, the A times B and the A times C both have an A. We can factor it out, put the A in front, and then have, well, what the A times B was with the A taken away and what the A times C was with the A taken away. That is just B plus C. And this can be really useful in a lot of different ways. One cool thing you can do with it, it can help people who have trouble remembering certain mathematics facts, multiplication facts. Let's say you have 8 times 7. Maybe this is one of those, the few ones. There's a few multiplications that everybody has trouble remembering. 8 times 7 is a popular one. The 9s are kind of tricky. 7s are kind of ugly. But you can split it up. You can say, well, wait a second. 7 is 2 plus 5. Well, let's say 5 plus 2. 7 is 5 plus 2. And so we can distribute the 8 and say, using the distributive property, this is 8 times 5 plus 8 times 2. And what I'm thinking is, maybe you can do this in your head. And maybe you can say 8 times 5 is 40, and 8 times 2 is 16. So together, this is 56. That's one way to remember that 8 times 7 is 56. It's 2 more 8s than 5 8s. 5 8s is 40, 2 more is 16. It's one way to do this. It also explains adding units. Adding numbers with units. And that is to say that if you have, let's say, 3 cats plus 5 cats, this is really sort of 3 times cats plus 5 times cats. And you can say, hey, they both have a cat in them. You can take cats out. Now, normally we factor out to the one side, but it doesn't matter which way you pull things out. We can call this 3 plus 5 times cats. 3 plus 5 is 8. We're talking 8 cats. Or if you wanted to say something like, well, you could explain why 4/5 plus 7/5. This is what? This is 4 times a fifth plus 7 times a fifth. This really bugs some people when you've got a fraction and they're like, what is that 4 doing? It's 4 over 1. It means the 4 goes up top. Anyway, they both have a fifth. So this is 4 plus 7 times 1/5. If you distribute it out, it's 4 times a fifth plus 7 times a fifth. And then you just get 11 times a fifth, which is 11/5. I know, not too many people have trouble adding number fractions with common denominators, but it helps explain why these sorts of things happen. We're going to talk about this later, but I just want, oh, I love the distributive property. Here you go, have some distribution.